Lesson 4-5B, plotting and analyzing residuals. Recall that a residual is the vertical distance between data point and a line of fit. So if you look at the diagram here, where you see the D, that would be the distance of a point to the line, and that is the residual. To calculate a residual, find the difference between an observed y value, or the value from the scatter plot, and its predicted y value from the line of fit. So to do that, we are going to use this example. The table in the scatter plot shows the sales at a car dealership from January to June in a recent year. The line of fit represents the predicted sales line in thousands of dollars X months after January. So they give us the line of best fit, and then we're going to use that to help us with finding the residuals. Now, January, X represents the months after January. So that means this would be 0, 1, 2, 3, 4, and 5. So if this is our X, we have to plug those into this equation. And then we're going to subtract that number from the given number that we have. So 62 times 0 is 0 plus 195. So I'm going to take, or 1194. So I'm going to take this answer and I'm going to subtract 1194 from here, and you get a negative 29.8. Next one, February is 1. So if I put a 1 in for X, 62 times 1 plus 1194 gives us 1256. So I subtract 1256 from here, and we would get an answer of negative 326.4. Next one, I'll show you this one on the calculator as well. I'm going to take 62 times March is 2, so multiply by 2. Then I'm going to add 1194 to it, and we get 1318. So we're going to subtract 1318 from here, and we get an answer of negative 19.6. Then our next one, put a 3 in for X, multiply it by 62, and then add 1194. You get negative 1380. Or subtracting 1380 from it, and we get a negative 1.3. We put a 4 in for X, and then add 62 times 4 plus 1194, we get 1442. So we subtract 1442 from 1436.9, and we get negative 5.1. And our last one, if you put a 5 in for X, multiply by 62 and add 1194 to it, you get a 1504. Subtract that, and we get 0.5. So here to use the equation to find the predicted sales for each month, practice from actual sales of the month to plot choices. So that's what I did. And you can see in this table here the numbers I got. And so if I rewrite those in here, we get negative 29.8. We get negative 326.4. We get negative 19.6. April, we get negative 1.3. May, we got a negative 5.1. And June, we had 0.5. You'll notice that here, this point right here, this one was furthest away from the line, which that stands out. That would be February. That one's further away. We would say that one's more like an outlier. That one's really far away compared to all the other data points. Part B says analyze the residuals. So if we analyze it, there is one positive, and most negative, and the rest of them are negative residuals. So that would be 5. So if we go back there, we had 1, 2, 3, 4, 5, 6 of them. 5 of them are negative, 1 of them is positive. Most of the data lie below the line of fit. We go back here, most of them are below the line. So below, 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 on. So we would say 3, almost half of them are below the line. The equation shows a blank correlation, but the residuals indicate that there may be a line that is a better fit. So we needed to determine what kind of fit. This would be a positive correlation. Next, the least residual is 0.5. So the absolute value of 0.5 is 0.5, meaning the predicted value is closest to the actual value. In a month that had 0.5, and the month that had 0.5 was June. So we would have June here. The greatest residual means the greatest distance away was the absolute value of negative 326.4, which is 326.4, meaning the predicted value is farthest from the actual value, and that was the second month, which was February. The greatest residual is significantly greater than the other residuals and corresponds to an outlier in the data set. So as I said before, that 326.4 would be the outlier, and normally you wouldn't do too much with that number when you're comparing the data. So that is our lesson on plotting and analyzing residuals.